All right, today we are translating equations, meaning we're going from a word problem like English to a math sentence. So that is like translating a language. So some helpful tips: define the variable, figure out what you are trying to find. That's usually in the question, like how many, and then that's your clue that that's your variable. So we will look for that and that'll help guide our equations. Then you just use your keywords to set up an equation. Your clue words are like your addition words. Literally the word plus is a clue word. Some common multiplication words will be each, per, every, but we will see those examples as we work through the problems. And then answer the question if it wants you to solve it, and make sure you're actually answering the question and it's a reasonable answer. For these first few, we are just going to define the variable and set up the equation. We will not solve these. We've done a lot of solving already. So starting out, we're gonna start with basic ones and move on to harder and more complex ones. But this first one says, Connor deposited $84 into his checking account. If his new balance is $451, what was his balance before the deposit? Now remember, we are not solving it. I'm sure that your wheels are already turning and you can identify how to get the answer, but that's not the goal. We are just setting up an equation. So when it says what was his balance, that's our unknown, that's our x. So we're gonna say let x, I'm just gonna put let x equal balance. And so remember, our equations are like 5x plus 2 equals 10. It's not just a math sentence. So we need to write an equation revolving around x, revolving around the balance. So when it says Connor deposited $84 into his checking account, that word deposit means he added it in. So he had a balance, he had money in there, that's x. We don't know how much it is, but then he added money, so we can put plus $84. He added money, and his new balance, so that gave a total of, it equals $451. And that's all it's asking for. That's our equation. His balance, he added 84, he deposited it, and then that was the new total. And that's what we're doing. So number 2 says 6 adult tickets to a movie at the theater cost $52.50. Find the price for one ticket. So again, there's that kind of instruction, the price for one ticket. So that's what x is. Let x equal price of one ticket. So think, what would we do to the price of one ticket? What are we gonna do to x based off this problem? 6 tickets cost $52. So that's the total. That's our clue that something is gonna equal $52.50. So what do you do to one ticket cost to get that total? Well, you buy 6 of them. So you can either do x plus x plus x plus x plus x plus x, or that's just repeated addition, that's multiplication. 6 tickets, if you take 6 times the cost of one ticket, that gives you the total. And that's what it's asking for. Sometimes when they're super simple, we tend to overcomplicate them. Okay, number 3, 3/4 of the 8th graders at Kingston Middle School went on the class trip. If 252 students went on the trip, how many 8th graders are there? So let x equal, what is it asking for? How many 8th graders? So x is your 8th graders. Okay, and so what does it say about the 8th graders? What does it say about x? 3/4 of them went on the class trip. And that amount is 252. So we know, again, that's the end amount. And so what would you do to the total number of 8th graders to find that portion? Well, it's just 3/4 of them. So you would find what 3/4 times the total is, and that gives you that amount. Okay, number 4, after falling 23 degrees Fahrenheit, the temperature is now, that's kind of your end amount, now 51 degrees. What was the starting temperature? There's our question, so that's our variable. Let x equal starting temperature. I'm just gonna abbreviate and say temp for temperature. So what happened after the starting temperature? What happens to x? It then falls 23 degrees. Mathematically, falling is dropping, subtracting. It goes down 23 degrees. And it is now the end result, it equals 51 degrees. There's your equation. Okay, let's level up a little bit. Stephanie is registering her son for swim lessons. There is a one-time $45 registration fee plus, well, that's an obvious math word, a $20 fee per lesson. That's a math word too. Stephanie paid a total of $225. For how many lessons did Stephanie register? That's the question. How many lessons? So that's what x is. The variable is lessons. So x is lessons. And so think, what would you do to that number of lessons to find your total? If it told us the total, we know that that's on the other side of the equal sign. So sometimes that's easiest to fill in. Well, you paid a $45 registration fee. So that's what you're starting to pay. Plus, that means add $25 per lesson. Well, we already said lessons was X, so it's $20 per, meaning times the number of lessons. So this one, we could really just write out the equation as we read it. 45 plus 20x. I think that per means multiply. Okay, you could write this in a different format. You could say 20x plus 45 equals 225. That's perfectly fine. They mean the same thing. The cost for one lesson times how many lessons they take, and then you have to add on that registration fee. That's how you would calculate your total. Okay, so you can kind of see a difference. These equations were much shorter. There was just one other number. These, there's multiple components. Okay, so number 6, Mrs. Bultice rented a car for one day. The charge was $36 plus $18 per mile. If the total cost of the rental was $60, how many miles did she drive? So there's our question, so we know that x is miles, since that was the question. Number 6 is very similar to number 5. We can really write our equation like we read it. We have to pay $36 plus the 18 cents per mile. So we would have to pay 18 cents for every mile. So you would have to multiply that by however many miles you have. So we're gonna put it next to x because that means multiplied by the number of miles. And we know that the total cost, so total equal, is $60. So that's our equation. Again, if you wanted to rewrite it so that variable comes first, you could. It's all the same thing. It's a personal preference, but they mean the same thing. All right, number 7, a plumber charges $55 for a service call plus $35 per hour. We're seeing a lot of similar math words. If the plumber's invoice was $160, how many hours was he working? The question is how many hours, so that's what x is. Let x be hours. Now that word invoice, that just means like the total you have to pay, like your total bill. So the plumber's total was $160. So again, you have to pay $55. You can start with that. Plus, you also have to pay $35 per hour. So $35 for each hour, which is X, to give you that total bill of $160. Okay. Now number 8 is like a more geometry problem, which we have seen before. It says the perimeter of the rectangle shown is 36 inches. Write and solve an equation to find the value of x. Okay, perimeter. You have to understand what perimeter is. Perimeter is adding all the sides. Add all sides. And then it says the perimeter is 36 inches, so it equals 36. So to write an equation, we're gonna add up all the sides and it's gonna equal 36. Now notice that they're only giving you this side and this side, but we know that a rectangle, the opposite sides are the same. So this side is also 12, and then this side is the same right here, so 4x minus 6. So now seeing that, we're adding up all the sides. You can go side by side. You can say 4x minus 6, that's this side, plus 12, plus that side, plus this side, so plus another 4x minus 6, plus 12. You can do that. That all equals 36 because the perimeter is 36. Or you can simplify it. You can either combine your like terms here. So remember, your x's are like terms and then your constants are like terms. You can do that. Or if you can look at this shape and you can already recognize that, hey, our like terms, 4x and 4x, and then all of the normal numbers, you can combine from there also. It's your choice because this is kind of overkill to write out, okay? But regardless, whether you simplify this or you do some mental math, the 4x and 4x is 8x. And when you add up all these constants, negative 6 plus 12 is 6, minus 6 is 0, plus 12 is 12. So 8x plus 12 equals 36. That's the simplified form of it. So that will fit in my blank. So I'm gonna say that's the equation, 8x plus 12 equals 36. That's the simplified equation. Now this one does want us to solve. So this is when we wanna get x by itself. So I'm gonna draw my line and I'm gonna do those inverse operations. I wanna get rid of 12. I'll subtract 12. So I'm left with 8x equals, that's 24. And then x is not by itself. I need to divide by 8 to cancel out the 8. So x is 3. 3. Okay, so that missing piece in there is 3. Okay. All right, number 9, similar but leveling up. The square and equilateral triangle below have the same perimeter. Remember, that means equal. The perimeter of this is equal to the perimeter of this. Find the value of x, then find the perimeter of each shape. Okay, so a square, hopefully you know that a square means all the sides are the same. So this is the same thing on all 4 sides. An equilateral triangle means that all the sides are the same. Okay? So, again, there are several ways that you can do this. I would say that the simplest way to think about it is there's 4 of these. So I'm gonna take 4 times that. Instead of saying this, plus that again, plus that again, plus that again, I am going to write it as 2 and 1/8x plus 30. And then that equals the triangle one. So similarly, there's 3 sides. So instead of saying this, plus this, plus this, I'm just gonna say 3 times 5 and 1/3 x. Okay, now I don't like doing this kind of math with mixed numbers, so I am gonna convert them to improper. The calculator can help you with that, but 2 and 1/8 is the same thing as 17/8. So I'm just gonna rewrite it that way. And then 5 and 1/3 is 16/3 x. okay? And then I'm gonna simplify. Remembering our order for these multi-step problems, don't call me after midnight. That first piece reminds us to distribute. So that's what I'm gonna do. I'm gonna distribute 4 times 17 over 8x. And that simplifies to 17 over 2x. And then 4 times 30 is positive 120. And then same thing, we're gonna distribute the 3 to the 16/3, which is just 16, so 16x. So that's distributing. I do not have like terms. Remember, on this side, those are not like terms. On this side, those are not like terms. And so now I just want to move my variable. So I'm gonna draw the line, and to move this, I just subtract it. 17 over 2x minus 17 over 2x cancels it out. So I'm gonna do that on this side. And that equals 15 over 2x. Okay, these two things are being multiplied, so I'm going to cancel that out by dividing on both sides. And so 120 divided by 15 over 2 is 16. So 16 equals x. Okay, so I would say the equation, I mean, our work is all over here, but I'm gonna say the simplified equation is what it's asking for. So I'm just gonna copy that, 17 over 2x plus 120 equals 16x. And then we said x is 16. Now it does want the perimeter of the shape. So now that we know what x is, we can just plug that in. So I know that to find the perimeter of the square, it is 4 times all of that. So 4 times, remember we said that was just 17 over 8, times x, so times 16, plus 30. So I just copied down that equation right here, and I'm doing that 4 times for all 4 sides. And I replace the x with my answer. Okay, and that's just a Desmos type in. You're gonna type exactly that into the calculator, and you should get 171. And since these are the same, you should get the same answer. You can double check by doing the same thing with the triangle. You can take 3 of that triangle length, which is 16/3 x, and then instead of x, put in your answer. But you will get the same answer. Okay? All right, number 10, this is kind of like multiple choice. It says for A and B, determine whether the equation below correctly represents the situation. If so, write yes. If not, write no, and the correct equation for the situation described. So in a problem like this, I just think it's easiest to read the situation and write an equation as you read it. So it says Jill's bowl of pudding contains 12 ounces. So she has that, that's what we're starting with. And she eats 1/10 of an ounce each second. So think she's eating, that is taking out of the bowl. So that is subtracting 1/10 of an ounce each second. So that's our clue that that's our x, each second. And you can kind of fast forward and read the question, how many seconds? So you know that x is seconds. So 1/10 for each second. Barb's bowl of pudding contains 1/10 of an ounce. So just over here, I'm gonna put 1/10 of an ounce. That's what she's starting with. And she's adding 2 ounces each second. So I'm gonna put plus 2 each second. So that means 2x. Then the question says, after how many seconds will the 2 bowls contain the same amount of pudding? So when will Jill's be the same, meaning be equal, to Barb's? So this is our equation. We can see if it matches. So the first part looks like it matches, but the second part does not, because we put 2 with x and this one does not. So no, that does not match the equation, and we've already found the right one. Okay, so B, it says Raven runs 12 miles throughout her first week of training, so that's what she starts with, and decreases, meaning takes away, her total distance by 1/10 of a mile each week. So she goes down 1/10 each week. That clue word each tells us that's where our x. Then Josh runs 2 miles during his first week, so he starts with 2 miles and increases, so he adds his total distance by 1/10 of a mile each week after. So similar, add 1/10 x after. How many weeks will Raven and Josh run the same amount? So we want Raven and Josh to be the same. That would be our equation. Okay, and so now we match. The first one match, the second one matches. So yes, it is a match. Okay, a lot of times you have 4 answer choices and you have to circle which situation will match the equation. But that's the best strategy I recommend. Just write the equation as you read the problem. All right, last page, 4 problems left. These are the most advanced ones we'll get. They're very similar to that last one we did. So celebrity A has 400 followers on social media and is gaining 75 followers each day. So starts with 400, gains 75 followers each day. Celebrity B has 1,000 followers on social media, but is losing 25 followers a day. How many days will it take them to have the same number of followers? So when it says let x be what it's asking for, how many days? Let x be the days. And it wants them to be the same. So I like to write, when I start my equation, we want celebrity A to be the same, be equal to celebrity B. Now it gives us a lot of information. So one strategy to help you stay organized is color coding. So celebrity A, I'll highlight in blue, has 400 followers and is gaining 75 a day. Now celebrity B, that's a different category, so I'm gonna use a different color. Celebrity B has 1,000 followers, but is losing 25 a day. So we need to make sure that all of our B numbers stay together and all of our A numbers stay together. We don't want to mix them, otherwise our equation will be wrong. Okay, so we're first going to start out, how do we write an equation to match celebrity A's information? They start with 400 followers, so we're going to start with 400. Gaining means adding, so we're adding 75 followers each day. So we're adding 75. That clue word each is our x. Since x is days, each day. Now celebrity B, that's our yellow, has 1,000, so that's what we're starting with, 1,000, and is losing, that means taking away, subtracting 25 followers a day. So that would be 25x, because x is days. So that is our equation. And now it does want us to solve it. So this is when you draw your line and you can go through your steps. We do not have distributive property. We do not have like terms. We just need to move the variable. So I'm gonna move negative 25x by adding 25x to both sides. So that will leave me with 400 plus 100x equals 1,000. Okay, so that was moving the variable, and now we have a normal equation where we follow our normal steps. I'm gonna take care of that addition of 400 by subtracting 400. So I'm left with 100x equals 600, and then I will divide by 100, divide by 100. And that leaves me with x equals 6. And then what does x represent? Remember, x is days, so we could even say 6 days. Okay. All right, and that is reasonable. On a problem like this, if you got a negative answer, that would be alarming because you can't have negative days. So you can check for reasonableness now that we have word problems. Okay, next one. Ben and his friends are going to play putt-putt. At one location, they can pay $2 for rentals plus $7.50 per game. At another location, it would cost $8 for rentals plus $6 per game. How many games would they have to play? So how many games, that's our focus, would they have to play in order for either location to cost the same amount? So we want one location to be equal to another. So again, I'm gonna color code one location, that's this one. They can pay $2 for rentals plus $7.50 per game. So we can just start with that. $2 is what you have to start with paying. You can put 2 with the decimal or not, doesn't change the number. Plus $7.50 per game. That's where our X is. And I know that X is games because it says how many games. I should have filled that in right away. X is games. Okay, then it says at another location. So that's a separate category, another location. It'd cost $8 for rentals plus $6 per game. So that needs to go on the other side. Starting with an $8 payment plus $6 per game. So that's where our X is. Okay, we have our information organized. Now we can solve. Don't call me after midnight. There is no distributive property. There are no like terms, but I do need to move the variable. So I'm gonna move 6x by subtracting 6x. So then I'm left with 2 plus 1.50x equals 8. Okay, I moved the variable. Now it's a normal problem. I'm going to cancel out that 2 by subtracting 2. So I'm left with 150x equals 6. And my final step is to divide by 150. And that is 4 when you divide. So x equals 4. For what? X is games, so 4 games. After 4 games, it'll balance out, and that is reasonable. Okay, Haley has $155 in savings, and her brother Hank has $230. Haley is saving $10 each week, and her brother is spending $15 each week. After how many weeks will their savings account have the same amount of money in them? So X is weeks since it says how many weeks. And we need their savings account to have the same. So Haley needs to match Hank, needs to be equal to Hank. Now this is when that color coding is super duper helpful because we have information unorganized in here. So I'm gonna highlight Haley's information in blue. She has $155 and Haley is saving $10 each week. Now I'm gonna highlight Hank's information in yellow. Hank has $230 and he is spending $15 each week. Okay, so now I'm gonna write that out. Haley has $155. So that's what she's starting with. And she's saving $10. So if she's saving it, that is getting added to it, plus 10x. Hank has $230. That's what he's starting with. And Hank is spending $15 each week. If he's spending money, that money is leaving. It's being subtracted from his account. So he's taking out $15 every week. That week is our x. This would be our equation. Now we solve it. Don't call me after midnight. No distributive property. No combining like terms. I just need to move my variable. There's my smaller one, so I'm going to add 15x. So that is 155 plus 25x equals 230. I move the variable. Now I do my normal steps. Get rid of the 155, that's the constant. So I'm left with 25x equals 75. And then I need to divide by 25 on both sides. So x equals 3. And again, x is weeks, so that means x equals 3 weeks. After 3 weeks, Haley and Hank will have the same amount of money. Again, that's reasonable. All right, last one. Isabel takes the bus to work. The bus ride to work costs her $2.50 each time. She could buy a bus pass for a one-time fee of $15 and would then only pay $1 each time to ride the bus. How many times would she have to take the bus in order for the cost to be the same? So notice all of these problems are the same because they have that word same in there. So how many times would she have to take the bus? This one isn't as clear in what we can define x as, but how many times would you have to take the bus? That means her bus trips or her bus rides. So x is our bus rides, okay? And so the thing that we want to be the same would be the cost if she has a bus pass and the cost if she doesn't have a bus pass. So we can just write that. No pass cost needs to be the same as with a pass. Okay, so now we color code that information. If she has no pass, then she would have to pay $2.50 each time. If she has a pass, so she could buy a bus pass for a fee of $15 and then pay $1 each time. And so now that we have that color-coded information, we know what info to put on which side. So she has no pass, she has to pay $2.50 each time. That's our x. Okay, so notice there's nothing extra being added on, and that's okay. Not every problem has that. Now, if she has the pass, she has to pay $15 and $1 each time. So you could see that as 1x or just x, whatever you prefer. But $1 per ride. And now we solve. Our steps are don't call me after midnight. No distributive property. No combining like terms. I just need to move my variable. That's my smaller one, so I'm going to move it. I get rid of it by subtracting it. 250x minus 1x is 150x equals 15. And then I just need to divide. So x equals 10. And again, x is our bus rides, so that means 10 bus rides. Again, that's a pretty reasonable answer. All right, those are your notes.